Hi all, hi once again. So in this video we are going to discuss this is part 2 for distance vector routing, where we will be discussing about the coding, C coding part. So in the last video we had discussed on how to generate the final next hop matrix and the cost matrix following the same algorithm. Okay, so now let us see how to get the algorithm and the routing tables displayed for distance vector routing. So here we don't have any other function apart from the main function. Okay, so this code, DVR code, is much easier than your Dijkstra's algorithm. So if you have understood Dijkstra's algorithm, this is going to be very simple. Okay, so the first header file which we are going to use is stdio.h. Okay, this is included in order to use printf and scanf statements in the coding. Now let us start with the main function. So since we have not used any other function or function calls, so we have not declared any variables globally. So everything is inside main function. Okay. So what are the two main matrices which we have to declare? One is next hop and one is cost. So here is the declaration of next hop and cost matrix. We are initializing it. Okay, you can keep 10 also, no problem. So as in Dijkstra's algorithm, we had kept 10, 10, right? So this is a two-dimensional array for next hop matrix and the cost matrix. And then we need n for the number of nodes, I for the source, j for the destination, and k for the via path. Okay. So as in Dijkstra's algorithm, the first step is to accept the number of nodes from the user. So we are accepting the number of nodes because we want the code to be generalized. Okay, so you can do it for any example, not just the example which we had discussed in the previous video. Okay, so you can for any example. So here we have used the example with number of nodes as 5. So let us accept n as 5. So enter the number of nodes. Okay, and then n is an integer, right? So percentage %d, then ampersand n. So here we will be accepting n from the user. Next is accepting the initial cost matrix. So enter the cost matrix. So accept from the user, right? Yeah. So we're just printing enter the distance, or so I said this cost matrix can also be called as the distance or weight matrix. Okay, so you can use any of these terms. Enter 0 for same node, right? The diagonal elements, and 100 for no direct connection. Clear? Yeah. Now, so first is we have to print the column numbers, correct? So that is all same. So you can actually copy paste this code from Dijkstra's algorithm and then make the necessary changes. So these are all the same. Print the column numbers first after a tab, right? You remember that, right? And then print the row numbers one by one. And while you print the row numbers, you should be able to enter the cost matrix. So that is ampersand cost, scanf ampersand cost of ij. Okay. And the only difference is this. So in the previous Dijkstra's algorithm, you can see, yeah, this is Dijkstra's algorithm. Okay, so here we had used path matrix. The initialization was 0. Here it is j. Okay, so but that's why it is called as next hop matrix. So the next hop when you move from I to j is nothing but j itself. Okay, so the next hop of matrix is all initialized to the destination j. So that's the change here you can see. So within this loop, what all is done? You have accepted the cost matrix from the user. So cost of ij is ready. Initial cost matrix is ready. And you have initialized the next hop matrix also to all j's. So initial next hop matrix is also ready. Okay, so if you want, you can print the initial next hop matrix for your reference. Okay. So next is, so let us see till here in the output window. Yes. So enter the number of nodes. Okay, so that is 5. So see this, enter the number of nodes. So 5 is accepted in n. Enter the distance, cost, or weight matrix. So enter 0 for same node connection and 100 for no direct connection. So that is your wish, 100, 200, anything is fine. We are just entering a higher cost value. That's it. Since we can't enter infinity. Okay. So what is our cost matrix? Let me just check. One second. I just have to refer it from the previous PPT. Yeah. So initial cost matrix is what we have to enter. So you can see the column numbers are printed after a tab, and then you have given a tab after the first row number. So now we are able to enter here because you had given a tab. So here it is 0, 1, 10, 3, 20. So I'm entering using a tab in between each values of cost matrix. So as I press enter, you can get the second row, 1, 0, 2, 100, 100. Third one, 10, 2, 0, 100, 4. So this is the same initial cost matrix which we had seen in the PPT. So I hope you have written all these in the observation also. So maybe you have to submit it in Google Classroom, right? 300, 100, 0, 1. Fifth one, 20, 100, 4, 1, 0. So that's it. So we have done entering the cost matrix. So as I press enter, the algorithm would be, so cost matrix would be initialized and simultaneously, meanwhile, in the same loop, we have initialized the next top matrix also. So that also would be initialized to all J's, correct? And then the algorithm will run. So see this. So it's huge thing. Don't worry. So let's see one by one what happens. So I printed the final cost and next hop matrix after the algorithm. Okay, so 1 second. Okay, so here now, so what is the algorithm? It's the same thing. Okay, you just have to copy paste the same Dijkstra's algorithm. The base loop is K. Okay, so this is for K. That is the via node. Okay, and this is for the source node, right? And this is for the destination node. Correct. So that's what we just discussed in the previous video. Then if the cost of the previous via node or the previous loop is greater than the current summation, which is following the via path. So we had taken an example of 2, 4. So if the source is 2 and the destination is 4 and the via node is 1. So the actual value of 2, 4 in the initial stage is 100. So 100 is greater than. So if 100 is greater than, we'll get cost value of ik. Ik is 2 to 1. 2 to 1. 1 plus 4, correct? So cost of 1, 4 is 4. So 1 plus 4 is 5. So 100 is obviously greater than 5. Hence, the new cost value will be replaced with the summation, that is, the value will become 5, correct? And simultaneously, the next hop matrix, the same next hop of 2, 4 will become 1 because this is in which loop? K equal to 1. Okay, so this is how, using this few lines, the algorithm will be implemented. And soon after this bracket, what will be done? Cost matrix will be updated because K is traversing all the 5 loops, right? And at the end of this loop, cost matrix will be updated and the next top matrix will be updated. And whatever we'll get will be the final cost matrix and the final next top matrix. I've just printed the final cost matrix here and the final next top matrix here. The same thing is shared with you in Google Classroom, the code, okay? Now, final cost matrix, how to print? Same way. Just copy paste the way you accepted. So print the column numbers first and then print row numbers one by one. Okay. And then just print cost IFJ, INJ using a tab. Don't forget to give this tab, otherwise it will come together and then it will be very confusing. It will look like a single number. Okay, not separate values. Clear? So similarly here also, and just print the next hop matrix. So that's how we saw the output screen. You can see final cost matrix is printed here. You can cross check this with your manual calculations. Final next hop matrix, this one. Okay. So now our cost matrix is ready in cost of ij. Next hop matrix is ready in next hop of ij, right? So now how to print routing table. So just see this. if you see this here, the routing table, see this. So this is how the routing table is printed. Okay, so I'll come show you this, and then we'll go back to the code. So routing table info for router 1. So 1, 2, 3, 4, 5, like this, 5 routers. And then for each source node, so this is the source. For one acting as the source, what is the destination? What are the possible destinations? What is the next hop for those destinations? And what is the distance or the cost? So for 1 to 1, the next hop is 1, the distance is 0. So that is obtained from the cost matrix and next hop matrix itself. Okay, so this is how you are printing. And then the routing table for router 2. So these things are same. So it is basically running 5 times, that is equal to the number of nodes. And then you're just printing destination, next hop and distance from these cost and next hop matrix itself. You don't have to go anywhere else, correct? So you're just printing this values from next hop matrix, these values from cost matrix, and this from J. So this destination is nothing but J. This is next hop of IJ. This is cost of IJ. Clear? And this is I. So you basically have to print I here, J here, next hop of IJ here, cost of IJ here. And then run it for how many times? 5 times. So you have to put a base loop I equal to 1 to 5. That's it. Okay, so that's all. So now let us see the code. Okay, see this. So so you just traversed quickly. So first we accepted the cost matrix from the user, initialized the next hop matrix, and then we wrote the algorithm where the cost and next hop matrix will be updated up at the end of k equal to 5. And then we just printed the final cost matrix. Then we printed the final next hop matrix, and then we are now printing the routing table. Okay, so what is this, how to print? So I told you 5 times you're printing, right? So the base loop is 5 times. So I equal to 1 till 5, correct? And then routing table info for router number, what, where is this number available? In I. So I will be printed here. Router %d, in that I will be printed. So one by one it will be printed. And then you're printing, below that you're printing destination, tab, next hop, tab, distance. So you can put it as distance or cost or weight, anything. Okay, so distance. So you give the space, otherwise it will be confusing. So tab is important. Or you can directly give, instead of tab, you can just give like this space, no problem. Tab will definitely, like, it will define it properly. The alignment would be proper if you give tab, because you don't have to manually give the space, right? So now the order is destination, next hop, distance. So print in the same order. So then in the next loop, so start a new loop, J is the destination, right? And then print. So what is destination? %d. Next hop, %d. Distance, %d. So what is the first %d? J, because this destination is J. What is the next %d? Next hop of IJ. What is the third %d? Distance, cost of IJ. That's it. So you just have to print it here in the same order. Then close the for loop, close the main function. That's it. So that's all for distance vector routing. Same thing is obtained here. Routing table information 5 times. Okay, so destination, next hop, and distance. So it is just for each router, the routing table information for the source to the corresponding destination, that is the next neighbor. So 1 to 1, 1 to 2. So these are the immediate neighbors for this, correct? No, like that. So the immediate neighbor information is available. What is the information? What is the next hop, and the what is the cost for the transmission? So this is the routing table information which is generated by the distance vector routing. Okay. So in real-time scenario, this is not how it happens, right? So we have the restriction that we are just doing everything in just C++. So we are just applying the logics and then displaying it in such a way that it looks like distance vector routing and Dijkstra's algorithm and so on. Okay. So in real-time scenario, this is not the case, right? Here we are just implementing the logic and then just displaying how it would be. Okay. So that's it. I hope you've understood. Thank you. If any doubts, you can just ask me anytime. Okay. Thank you.